Hello, everyone. Good afternoon. I welcome you all once again to the mathematics class. So, towards the end of the last class, I introduced the concept of identities, or what we can commonly refer to as the algebraic identities, because when we view the way mathematics is structured, we have different categories of identities. As we have algebraic identities, we also have inequality identities. We also have trigonometric identities, inequality identities, and so many identities. But the identities we are interested in now is the one we commonly know as what the algebraic identities. And this is the basis of any other identities that we may need to study in the field of what? Mathematics. Thorough understandings of these identities enable us to understand any other form of identities that exist in mathematics. So as a result, it is important. And the exam which we are preparing for, which is the IMO, the International Mathematics Olympiad, that will start from local governments, which later increase up to the level of national level across Africa, then across the world, requires the knowledge, full understanding of what? Of these identities. When one understands these identities very well, we can solve a very complex question. It can be applied in dealing with so many complex questions. So without wasting too much time, let's begin. Right, so if we can recall, those important identities that we need, as far as the syllabus we are to cover is concerned, so I copied them out the other time. So we have identities that involve just two variables. We can have identities that cover up for three variables, and we can have for more variables. But today, in today's class, so we want to solve one or two questions that has to do with what? The application of identities that has to do with what? Two variables. One of which is, as we have it here, so it's when we have a plus b squared, right? So the identity for a plus b squared simply means a squared plus b squared plus 2ab. So this identity works as a formula. But the only issue with it is at times when we are given a question, we will not know exactly which of the identity we are to use. So that's the reason why it is important we fully understand these identities, right? So in fact, it also enables us to solve questions as fast as possible. For instance, we began this class by talking about the Pascal triangle mode of expansion. When we know this identity very well, we can see this identity we have here is a result of the application of the Pascal triangle means of expansion or any other means by which this thing I have here can be expanded. So which means when we have a plus b in bracket squared, right, the formula for dealing with any such question that have this pattern or any such question that have this structure is simply this. So instead of really wasting time solving this question using our normal Pascal triangle, going to the extent of constructing those 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and so on. So once we are able to remember this identity, we solve that easily. So which means expanding any expression, right, of this pattern, right, which has this as its identity, right, can be easily done. In fact, under a few seconds, we will have what? Concluded the answer rather than still applying our the process of expansion, introduction of those coefficients and the rest. Also, this idea of identities also enables us at times to solve questions, right, by not following the normal procedure by which such questions can be solved. So we know there are some questions. In order for us to deal with them or to treat them or to solve them, we need to make use of system of simultaneous solution, especially when it contains two different questions, two different equations rather, right? So with this knowledge of identity, we may solve the question and arrive at the answer without having cause to what? Apply the concept of what? The concept of simultaneous equation, all those elimination method, substitution method, and the rest that we have. So that is one of the benefits of identities. It enables us to solve a very complex question within a very little time. So we have this, we wrote this, we copied this the other time. and also told us about how this thing derived. So for a student now, so all you just need to know is when we have a question which follows the pattern of a plus b squared, right, like this, so this is what you need to just remember. So this one didn't stop us from applying our Pascal triangle. It is possible at times we are given question like this that we should expand this thing using Pascal triangle. If the question come in that manner, apply your Pascal triangle as we have been doing. Consider whereby we have this thing, suppose we are doing an objective exam and want to do it as fast as possible, or we have any mathematical problem we want to solve. So if we want to get the result as very fast as possible, so we simply go by the identity. So this concept of identities then come, right, to tell us to forget what we have learned, or to tell us that those things which we have learned some times ago is not relevant again. No. So it is only used in order to make our process of solving problem to be more easier and to make it very quick and faster. So these are the basic identity. So it is recommended that students knows this thing offhand. That is, it is important we memorize this thing. Well, the process of memorizing this thing depends on how many questions we solve. So the more questions student lay his hand on and solve, enable him to retain this thing. That is, this thing will just be part of him or her naturally. So as a result, the more questions we solve, the easier it is for us to do or to retain this. So whenever I have a question following this pattern or following this structure, what should just come to my mind is this pattern has the identity. That is, it is equivalent to a square plus 2ab. So I will bring examples now, so as to enable us to know how does this thing work. So example 1 now. So I'm asked to expand 2x minus 1 over 3x, everything squared. So that's our first expression which we are asked to deal with. We know there are many ways by which this thing can be approached. One way of approaching this thing is simply to say that what? This thing is equal to 2x minus 1 over 3 times 2x minus 1 over 3. That's one means by which we can carry out this expansion. Other means by which we can expand it is to do what? To apply those process of expansion under the Pascal triangle that we just did. That one can as well be used. And finally, we can also apply identity in doing this. But out of the three systems I made mention of, so making use of identity is the most easiest, the most simplest, and the most fastest way to dealing with it, right? So what I just need to do is the question given to me, I have to determine what is its structure. First of all, the power is important. Now, does it carry power of 2? Is it power of 3 that it contains? So we can see the question which we have at hand now has the power of 2. So once it has the power of 2, it's either I use this identity, or I use this identity, right? But this thing is not limited to just power of 2. We can see this one contain power of 2. This one contain power of 2. Though this one also contain power of 2, but we can see the structure of this is different from the pattern of the question which we have here. So which shows that using this identity, this third one, in dealing with this question is out of it, as far as this very question is concerned. So it is either I go by this identity or I go by this identity. So then the next thing is, let me check, look within the bracket. Now, how do we structure the expression we have within the bracket? So we can say after the first number, the next thing we have, after the first expression, what we have is minus. So meaning that I need to use the one that has minus out of these two. And it is this one that contains minus. So since this one contains minus, it shows this is the appropriate identity I will use in dealing with this question. So to solving it now, I will say solution. So what I have is 2x minus 1 over 3x squared. I will say this is equal to, and this thing is telling me that whenever I have expression of this pattern, we can see this expression follows this pattern. So once we know the given expression we want to expand, follow any given identity. Let's first of all write that situation, that sample identity that this thing resembles. it is important we copy it out. Therefore, we can give something like a squared plus b squared minus 2ab. So the reason why I'm choosing this one is because the question given to me has the same structure as this identity 2. So since it has the same structure as identity 2, so this identity is what I will use. And remember, the a which we have in this identity here, right, in this formula or this identity here means the first number, right, in what we want to expand. While b we have here means second item which we have, together with the sign that precedes it. So sign has to be considered. So solving this thing now, we can say this thing we want to expand simply means, now what is the first item we have in this bracket? So the first item we have in this bracket serve as a, while the second item we have in this bracket serve as my b. Alright, so what is the first item I have in the bracket? I can see it is 2x. So I will first of all write that item 2x. And we can see by this identity or by this formula, we are asked to, this thing must be squared. So it shows we have to square this 2x. Remember, in one of the corrections I made from the assignment which we did some days ago, right? So I corrected some of us that when dealing with a double expression like this, right? A double expression is when we have a number followed by a letter. But in that situation, in order to square it, so it is important to make use of what? We make use of brackets. But if it happens that what serves as this first item is just a single letter or a single number, introducing of bracket is optional. If we want, we can introduce it. If we want, we may not introduce bracket in that case. In short, what I just need is my first item square. So the first item in this bracket square. So I have done that to follow what we have here. So immediately after this, what I have is plus. So I will put my plus there. Now, b squared necessarily means that I should first of all identify the second item in the given expression. And we can see the second item in this given expression is minus 1 over 3x. So I have to write that first. Minus 1 minus, okay, let me write it very well. Let me have my plus there. So what I have here is minus 1 over 3x. And the instruction here is that this thing should also be squared. So squaring it means I will make use of bracket in this case. So the reason for making use of bracket is because the item I have, this second item from this bracket here, is not just a single value. It is combination of both number and letter, right? So it is important. So inability to make use of bracket here may make us to what? To miss to get the correct answer. After this one, then what we have next is minus. We can see 2ab, that means 2 multiplied by. A here means the first item from the bracket here, and we can see the first item is 2x. So that will be 2x. Then times b here means second item from this bracket, which is what? Minus 1 over 3x. So that will multiply by minus 1 over 3x. So in order to complete this, we only simplify further so as to be able to get the final answer. So from basic laws of indices, what this thing means is 2x squared means we should multiply we should repeat 2s 2 times. That is 2s times 2x. So we know that will give 4x squared. We say this is equal to 4x squared. Now, what we have here as well, okay, let me say plus. I'm also supposed to do or to square everything I have in this bracket. So which means 1 times 1 here. Okay, let me start with the negative sign. Now, this square I have here is applicable to everything we have within this bracket. So it means minus times minus, 1 times 1 over 3x times 3x. So if I do minus times minus, you know that becomes plus. So 1 times 1 here gives 1 over 3x times 3x here. That one will give 9x squared. Right? Now, then the next is this area here. Right? I can write this thing in fractional form like this. Over 1. So that I should cut where possible. So we can see x is here. It is as well present here. So x will cancel x there. What we have left here is minus 2 times 2 times minus 1. So we can see we are multiplying. Minus is multiplying minus. So minus times minus in that case becomes plus. We are going to see plus. What is 2 times 2 times 1? That gives 2 over. So we are left with 1 times 1 times 3. So which gives 3. And this is what? The simple solution to our first question. So this is by the way of what? Applying the identity. We as well can solve this one using the Pascal triangle mode of what? Of expansion. But remember, using identity makes what we want to do to be fast. It makes it to be fast. So that's that. So I will run this shortly. So example 2 here. We are asked to expand 3x squared plus y squared. All right, the next question is to expand 3x squared plus y, then everything squared. Now, we can use Pascal triangle mode of expansion to doing this, but because we are presently dealing with the identity, so we don't want to use Pascal triangle in doing this thing. So it is identity we want to use to do it. So the very first thing we are going to do here is to try and observe the pattern of what we are given. What does it look like? So we always start from outside. It contains the power of 2. So meaning that if I'm to apply any identity, it has to be an identity that has to do with power of 2 that I'm going to use. And if I'm to use such an identity, it's either going to be this, this, or this. Right? So that's the first step. So the next step is I have to consider whether those the structure contains bracket or does not contain bracket. So we can see it contains bracket. Since it contains bracket, it shows this is out of what can be useful, because the given expression contains bracket, while this one do not contain bracket. So this one cannot be useful in dealing with the question or in solving the question. Now the next thing is, even if it contains bracket, which means I can use either this one or I can use this one. But which of the two am I going to use? It has to be the one that combines the first element with the second element with what? With addition. And we can say it is only this one that satisfies such requirements. So as a result, this is the appropriate identity for dealing with this question. So I will simply just say that solution. So what I have there, copy or write out my question, 3x squared plus y squared. We say it's simply equal to, so this is the identity. So we quickly apply that formula to dealing with this thing. So from the formula, from the identity, so what I have first here is a squared. Remember, a squared here is the first item from this bracket. And what is the first thing we can see inside this bracket? It is 3x squared. So that shows we should write the 3x squared. And this thing has me to do what? To square it. So for me to square it, the better way or the best way by which this thing can be squared is first of all to cover it with brackets, and I can put the square, because every first item I have here must be squared. Since I have to square this, and this, then it is better I introduce bracket. So that's the first thing there. Then the next thing in the formula is I have plus B then means second item from this bracket. And what's the second item from this bracket? Plus y, you can write it as ordinary y. So that means y. And what should happen to this y too? By this formula, it needs to be squared. So this is what I said the other time. So you can see this is just a single expression. or let me say a single variable. If it is a single variable, it is optional. If we want, we can use brackets. If we want, we may not use brackets. It will in no way affect our answer. But if it contains two values, or rather, if it contains two variables, suppose 2y, 4x squared, and something like that, inability to make use of brackets, right, for the squaring, we affect our final answer. So I can decide to write it as plus y squared. So after this one, what I have is what? Plus 2. So remember 2ab there means 2 times ab. So I will simply say 2 multiplied by, what is a? A means the first item from this bracket, which is simply 3x squared. It means 2 times 3x squared. Now, 2ab here means 2 times a times b, so I will also say times. B here means what is the second item from this bracket, and we can see that is y. We are going to say multiply by y. So result of simplifying this thing is the answer to the question. So this simply means each of the item, we can see we have 2 items in this bracket. Each of these items has to be squared, right? So that is 3 squared, means 3 times 3. That will be 9. This one, x raised to power 2 times x raised to power 2. We can simply do that one here, x squared multiplied by x squared. We know from basic laws of indices, x squared times x squared will give what? X raised to power 4. So meaning squaring of 3x squared here will give 9x raised to power 4. Plus, there is nothing to do here because y squared is in the simplest form. I will say plus y squared. Then finally, I have to multiply what I have here. So the way to doing this multiplication is to say 2 times 3. That gives 6. X squared times y, that is x squared y. And this is what? The answer or the solution to our second question. So from what we did now, we can see that making use of the identity. Remember, this identity is a result of earlier application of binomial expansion or Pascal triangle expansion. So making use of those final results, right, makes what we want to do to be easier. It makes the solution to be faster. So in this case, we don't have to waste much time, especially if the question is an objective pattern. So we can easily get the answer without wasting much time, and we can still have additional time to attend to what? To other questions. So this is the solution to the second question. This also shall be rough shortly so that we can move over to the next question. Example 3. Expand. All right, this is our next question. We have to expand 1 over 4a minus 1 over 2b plus 1 squared. Now, when we observe this question, so we are going to realize that, okay, well, the very first thing I said we have to do is to consider the structure this thing follows. So we can see that the first case, second case, and third identity we have here, we have square outside. So it's either I apply this or I apply this. But when I get within, inside the bracket, so what I have here is not in line with the structure of the first identity and the second identity here. So which means in order to use this, either this identity or this identity, I have to modify the way this thing is done. So remember, this thing only provided for what? For just 2 entries within the bracket. But here we are having how many entries within this bracket? We are having 3 entries. So once we have 3 entries like this, then it shows this identity may not work. So in order for us to apply this one, so let us adjust the question. So to adjusting it, so let me adjust before I now render the final solution. So I can rewrite this thing as, it's the same thing as 1 over 4a, right? Even this 1 over 4a, I simply can write it as, what it means is a over 4, right? Now here, I can still write this one as b over 2 plus 1 over 1. I don't have issue with the first item, so everything raised to power 2. I don't have any issue with this first item. It's only that this second item here is expanded instead of them to what? To combine them together. And that is what we should do. So we still can adjust it to becoming a over 4, right? So let us just combine what we have here. So combining this one, we are going to say that minus, what is the LCM of 2 and 1 here? This is 2. So 2 into here is 1. 1 times b, that becomes b, plus 1 into here is 2. 2 times 1 here gives what? It gives 2. We say everything raised to power 2. So further adjustment here can become what? A over 4, okay, which we have done already. A over 4 minus b plus 2 over 2 raised to power 2 is what we have. So it is easier to work with this rather than working with this. So this is what we are now going to work with. Now we can see that it now has a structure similar to what? To the second identity on the list here. So since the structure resembles this thing, so the formula here is what I will just use. In that case, right, I will now say that what I'm to solve, solution. What I'm to solve, that is 1 over 4a. 1 over 4a minus 1 over 2b plus 1 squared is the same thing as, remember the structure is this second one, so a squared. What is it? Remember this thing is the same thing as this. Of course, refer to a, b, right? I will come to pick my a and b. Right? But remember this and this is the same thing. But it is this one I will use when I want to apply my identity or my formula. So remember, first item here is a over 4, and we have to square it. So in that case, I will say that a over 4 squared, followed by plus. Second one is plus b squared. B here means the second item. The next item we have within this bracket, which is minus b plus 2 over 2. So I have to square that one too. So to do that, I will say minus b plus 2 over 2, everything squared. Then minus 2 times, what here means the first item, a over 4, multiplied by b here means the remaining thing as outside the a over 4. So that will be multiplied by minus b plus 2 over 2. So the rest is just to simplify and get the final answer. So we can say this becomes, so remember here we should square everything we have within these brackets. So I can say a times a here gives a squared, 4 times 4 here gives 16, right? Then plus everything within this bracket is to be squared. We have other approach by which this thing can be done. Now I want to rewrite this thing in another nice way. This thing I have here can still be rewritten as 2 minus b over 2 squared. I don't know if this area is clear. So what I just did there was that I interchanged the position of negative and positive, because mathematically it makes much sense to have a positive number before the negative number. And we can see the addition sign here has disappeared here. Yes, we can write it this way. No, regarding the writing of plus, so depending on the situation, we can leave it, and at the same time we may not put it. So what I have here is still my plus 2, right? So I have to rewrite this in, then minus. So here, in order to do this place, let's just look for what is common. We cut where possible. All right, we can see the 2 here, we cancel the 2 here. All right, I will be left with minus times minus. That becomes minus times minus become plus now. Then I have a times minus times minus, that is plus, Abi. So what I have left now is what? Okay, minus times minus here is plus. So everything in the numerator is now positive. I'm only left with a plus 2. So that will be written as a bracket b plus 2 we say everything we have here is over 4. All right. It can be written as a squared over 16. A squared over 16 plus. Now look at what we have here in this middle here. In this place, what we have here also resemble this structure. So meaning that what? We can apply the identity of this second identity to dealing with this thing. That is one way by which you can approach it. Other way by which you can approach this one is to do what? To say 2 minus b over 2 times 2 minus b over 2. That is in the numerator level of this thing. We can see numerator correspond to what we have here. Look at the first structure: positive number, negative, negative, then this number, this number. It contains square, this thing also contains square. So that is, in order to solve this thing, I simply can apply this identity for this mid expression. So doing that means, remember the first item there is 2, which is our A. I can say that is 2 squared, right? Plus second item I have there is B. So which should be minus B squared, right? Then minus 2ab minus 2 times first item is 2, my second item is minus b, right? Then everything over 2 square in this case gives what? 4. We can now say here plus a into b plus 2 over 4. So we only need to simplify this mid expression and arrive at the final answer. So I can say this gives a squared over 16, right? Plus 2 squared here gives 4. Now remember, minus b times minus b here will become b squared. Now plus b squared here, so I can say plus b squared. Now minus times minus here gives plus, I can say plus 2 times 2 is 4 times b plus 4b, everything I have here over 4. Then plus a into b plus 2, everything here over 4, right? So I can say this is my answer, but there is a better way by which this answer can be represented. So there is a better way. So let me continue this thing here. Let me continue it from here. So I will just say it is equal to, right? So what I want to do here is I want to consider this other way by which this answer can be represented. So I can say that what? The LCM here is 16, right? So if the LCM is 16, so I can say this thing is equal to 16 into, all right? So 16 into, this place will now become, or let me say for, it becomes a squared, don't worry, this may create confusion for the students. So let me rather leave it in this pattern. So it has to be left in this form. Don't worry, in the future questions, when we will have gather much experience, then I will tell us much about how we can round up the answer. But for now, since we are learning for the first time, so that the information will not be too much, let's say this is the final answer for this. But one thing I want you to know is this thing can still be what? Be simplified further. But for the sake of what we are doing, let's say this is the answer to this. So that also completes the solution to the third question. Now simplify. Two x plus y, 2x minus y, then 4x squared plus y squared. Now this is the question at hand now. So we have to solve this question. So we know Pascal triangle expansion cannot be used in doing this. So what can come to one's mind is, let's open this bracket against this bracket. The result we get is you open it against this one, right? But there is a shorter version of rendering the solution to this question, and that's by the application of identity. So what we do in this case is, I will consider this and this, right? Look at this thing and this thing. Which of the identities does this thing resemble? So we can say there is one other identity. In fact, it is even our third identity. What is the third identity? The third identity states that what? A squared minus B squared is equal to A minus B into A plus B. And if you look at what is given to us here, it follows this pattern, right? Since if this pattern is given, so it means we are going to re-express this thing as this. And if this is given, we are going to write this. So we have just to match what we have here against this identity. Remember, this is the third identity. I hope that is taken. So 2x plus y, 2x minus y. When we look at this thing, it is like difference of 2 squares is applied to obtain what we have here. Now, if difference of 2 squares is applied in getting this, what is the actual question that was solved to get this result? The actual question that was solved to get this is exactly what this thing is saying, right? And we can see when we look at this thing, right? So it means this times this, right? We give this place. Why this times this? We give this place, right? So it shows that solution to this place and this place, right? Okay, let me say 2x plus y multiplied by 2x minus y, right? Against, okay, I don't need to do that. So let me just continue with the solution. I don't need to write all those ones. So let me just say my answer here is going to be 4x squared minus y squared. Remember, it's only when we solve this, that we are going to arrive at this result. I hope that is taken. So remember, what we just do in short is, whenever we have a question that follows this third pattern, that is this third formula or this third identity, what we are just going to concentrate on is only the first item here and the second item, right? What we are going to do is, we want to look for the square of the first item, and we are interested also in square of the second item. So square of this first item and square of this second item was the question that was solved, right? That gave this result which we have here. So that's exactly what we are going to do. Just pick this and this. Since this and this follow what we call difference of two squares, so it automatically shows that the question that was solved to arrive at this thing is square of this thing and square of this thing. And in between them, there must be what? A negative sign. So when we square 2x, you know that we give 4x squared. And when we squared y, that will give y squared. Right? So it shows that we solve this one. This one here will become this. Right? And we still have this to deal with yet. So I'm going to say bracket 4x squared plus y squared. Right? Remember, I've said we don't want to do direct multiplication. Doing direct multiplication is a waste of time, right? So that one is going to be a waste of time. The best thing we want to apply is still our identities. Now let us look at this thing once again. What identities do you think this thing follows? So remember, I'm not bombarding us with all the identities. We have about 10 lists of those identities. Those things has to be remembered anytime we are solving question, because solving this question means that we want to apply the identity to solving the question. And if you want to use something, automatically you must have that thing. You must know that thing offhand, right? So that's more reason why, for now, the whole exercise we are going to do in this class or in this video is going to specifically be based on the application of identity that has to do with square, right? Since it has to do with square, now let's look at the structure which we have here. Which of the three identities does it resemble? Remember the first identity, okay, let me say this is the third identity. There's an identity which says that a plus b squared is equal to a squared plus b squared plus 2ab. There is another identity which states that a squared minus b squared is equal to a squared plus b squared minus 2ab. 1, 2, 3. Now, which of these three identities does this thing resemble? And we can see what we have here, right, resembles this first identity. How? Because it means square of the first item minus square of the second item against square of the first item plus square of the second item, which is exactly what we have in this first case. So since it resembles this thing, then the next thing we should do is we only concentrate in the first item and the second item in one of the two brackets, right? And what we want to ensure we do is what? We will square this one and we will square the second one, and between them there must be a negative sign. So once we are able to do that, we've been able to detect the question that was solved to get this result. And actually, that is what we want to do here. What question was solved to get this result? So the way to doing that is, I will pick my first item, that is 4x squared. I will go and square it. I will also pick my second item, that is y squared. I will also square it. And in between them, there will be a negative sign. So that combination is the result we are looking for, which is what? The answer to the question which we are given here. So you can see this thing requires just 3 steps. And if we were to use normal multiplication, that want to open this bracket, then want to open this bracket, we know how many spaces we are going to occupy. We know how long it's going to take us. So which means if I square this thing, 4 times 4 here gives 16. S squared times S squared squared. That is S squared times S squared. That one gives x raised to power 4. And if I square y squared, that will give me y raised to power 4. Meaning that when we simplify what we have here, the result we are going to get is what? 16x raised to power 4, right? Minus y raised to power 4, which is the answer to this question. And I hope that is taken. So we still have more questions to solve before we call it a day. So here is another good question. This is example, I think example 5, right? So we are asked to simplify x minus 1 over x into x plus 1 over x into s squared plus 1 over s squared into x raised to the power 4 plus 1 over x raised to the power 4. So this is the next question which we want to deal with. So we can see that we have 2 ways by which we can solve this. So first approach is we can use this to multiply this. The result we get here to multiply this. The result we get from all this to multiply this, and we can get the final answer. And we know the road to getting that one will waste our space, will waste our time. If it happens to be an exam case, if we want to use that approach, it may make us not to be able to what? To not be able to do what? To complete the required number of questions which we have to solve. But there is a shorter way by which this thing can be solved. That shorter way is by application of basic algebraic identities. Now, to doing that, this thing will begin by considering these first 2 brackets, right? Now, what can you observe from this bracket, the element in this bracket as well as the element in this bracket here, right? So we can see what we have here. Let's link it to any of these 3 identities. Which of the 3 identities has this structure? So we can say it is not this, because the result of this identity of what I have here is this, and the result I have here is in no way like this. Also, in the second one here, the result of expanding what I have here is this. Compare what we have here to what we have here. Does it look alike? A squared plus b squared to plus 2ab, whereas this one is s minus something and so s plus something. So it is not this structure as well. Now let's check the third one. It is this one. Look at it. The first bracket is talking about the difference between first term and second term. And the second bracket is addition of this first number and this second number, which is exactly what we have here. Look at it. First number and second number are the same thing, right? The difference is in this first position here, in between them is minus. And in this second position, the difference between them, right, is what? Is plus. So meaning that this one corresponds to the identity first. This one I wrote as the first identity. So simply means that since it corresponds, we want to know exactly what question was solved to get this result. And like I told you the other time, if you want to get that question that was solved to get this result, I said just concentrate on one of the two brackets you have. So let's say we are using this bracket. It simply means we will square this number and you will square this number. The result it gives you, place minus in between them. That will give us the question that was solved. So the first item I have here is x. Why this item I have is 1x. In between them, 1 minus to be there. So in order to get the question that was solved, to get this result, you square this and square this. So if I square x, it will be written as x squared minus x squared over x. So 1 over x times 1 over x. You know that gives 1 over x squared. That will now become 1 over x. So let's get it. So this one now, this first two brackets has now been changed to one bracket here. I will now combine this with other one here. Now let's pick the other one here. So what we have here is x plus 1 over x squared. So we don't need to waste much time here again. So we can see exactly what we have here is what we have here. And the only difference between the two is that in the first one, minus was used to separate this term and this term, while here plus was used to separate this and this, meaning that it resembles or it follows the pattern of our identity 1 here. So once it follows the pattern of this identity, it means we want to get what question was solved to get this result, right? And for me to get the question that was solved to get this result, what I will just do is I should concentrate on either this bracket or this bracket. I will just pick those values I have there. I'll go and square those values. So let me use this place for that. So doing that, I have x squared. I have to square it. I will now say minus. The second value I have here, 1 over x squared. I also want to square this. So if I square this, x raised to the power 2, it means x raised to the power 2 times x raised to the power 2. That will become x raised to the power 4. So this now becomes x raised to the power 4 minus. So let us square this one as well. 1 over x squared times 1 over x squared. 1 over x squared times 1 over x squared. So we can see that becomes 1 over what? X raised to the power 4 minus 1 over x raised to the power 4. Now it shows this and this now becomes x raised to the power 4 minus 1 over x raised to the power 4. Then finally we have this. We now combine this as well so as to get the final answer. So I will now say against x raised to the power 4 plus 1 over what? X raised to the power 4. Now let's also look at the pattern. We can see the pattern here is of this structure. So once it is of this structure, what do we do in this case? We also try and verify the question that was solved to get this result. So let me put it here. I can now say my final answer is, and to doing that, what do we do? I will pick the first item here. I will pick the second item here. I will go and square the value. So what I have here is x raised to the power 4. I will square it. In between them, there will be minus. And I will say 1 over x raised to the power 4. In between them, I will also put what? In between them, there will be minus, then square, like this. And now, what is x raised to the power 4 times x raised to the power 4? So that would be, we simply can say 4 times 2 is 8. So this result becomes x raised to the power 8 minus what? 1 raised to the power 1. That gives 1 over x raised to the power 4 times x raised to the power 4. We know that gives x raised to the power 8. And this is the answer to this question. So solving this, 2x plus y, bracket 2x minus y, bracket 4x squared plus y squared gives this value. So this is the final answer to that question. So let me remove this so as to create confusion. So that's the solution to our fifth example.